Theorem 9-6 says if an inscribed angle of a circle intercepts a circle, then the angle is a right angle. So a semicircle is when we divide the circle in half, and that's when the chord happens to be a diameter. So I have diameter HF. I'll go ahead and draw the semicircle. So if I have an inscribed angle that intercepts that semicircle, then angle C over here should be 90 degrees. And first of all, let's think about that. So we have theorem 9-4 that says that if I have an inscribed angle, then that should be half the measure of the intersected arc. So if we already know that this is a semicircle, meaning 180 degrees, then it should make sense that that angle is 90 degrees. So I'll go ahead and show the measure. Okay, and the angle is 90 degrees. And once again, it doesn't matter where that vertex is for that angle. It will always be 90 degrees as long as it intercepts a semicircle. For this next example, we have the triangle ABD and triangle ADE are both inscribed in circle F. That means that the vertices are points on the circumference. With arc AB, this arc AB being congruent to arc BD. Find the measures of angle 1 and angle 2 if the measure of angle 1 is 12x minus 8 and the measure of angle 2 is equal to 3x plus 8. We have a triangle and one side of the triangle happens to be a diameter. That means that we are dealing with an angle, an inscribed angle that intercepts a semicircle. So that means that this angle as well as this other angle, they should both be 90 degrees. Anytime an inscribed angle intercepts a semicircle, then it would be a 90-degree angle. Now that we have determined that we have a 90-degree angle, we can go ahead and say the following: that based on the angle sum theorem, angle 1 plus angle 2 plus 90 degrees should be 180, and therefore that means that angle 1 and angle 2 are complementary, meaning the measure of angle 1 plus the measure of angle 2 should be 90 degrees. So the measure of angle 1, 12x minus 8, plus the measure of angle 2, 3x plus 8, is equal to 90. We have 15x is equal to 90, and dividing by 15, we get 6. So the measure of angle 1 is then equal to 12 times 6 minus 8, and this is going to be equal to 72 minus 8, so this is equal to 64. Now the measure of angle 2 is equal to 3 times 6 plus 8, so 18 plus 8, 26. Okay, so together both make 90 degrees, so that would be correct. Theorem 9-7. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So if we have a four-sided figure, then opposite angles will be supplementary to each other. They will add up to 180 degrees. So I'll go ahead and create a four-sided figure by connecting 4 points on the circumference of a circle. There's nothing special about, this figure that I've created, but we are supposed to get that opposite angles will be supplementary. So let's go ahead and show what the measure of the angles are for angle D and H. As you can see, angles D and H are supplementary. Okay, and once again, regardless of where those vertices happen to be. And same thing will be true for the other pair of opposite angles, E and C. Okay, so those two opposite angles are also congruent. So this demonstrates what the theorem says. As long as there is a quadrilateral inscribed in a circle, once again, that means that in this case, the four vertices are points on a circumference, then opposite angles are supplementary. They add up to 180. Example 4, quadrilateral ABCD is inscribed in circle P. If the measure of angle B is 80 degrees, the measure of angle C is 40 degrees. Find the measure of A and the measure of angle D. So angle B, 80 degrees. Angle C, that's 40 degrees. So we're going to apply the theorem, and we're going to look for angles that are opposite to each other because they will be supplementary. So opposite angle C, I will have angle A. So angle A and C are supplementary. So the measure of angle A plus the measure of angle C equals 180. So the measure of angle A is unknown, plus the measure of angle C, that's 40, and this is equal to 180. So subtracting 40, I will find that the measure of angle A is 140 degrees. Similarly, angle D and angle B are opposite to each other. So the measure of angle D plus the measure of angle B will be equal to 180. Measure of angle D plus 80 is equal to 180. Taking away 80, I get that the measure of angle D is 100 degrees.